Welcome to 7.5 Trig Ratios. We're going to get started by labeling using this word called opposite. So, if I want to name the side opposite angle A, opposite A will be away from A over here. So we're going to call this side A or BC. Notice opposite. If I started from angle B, the opposite side would be AC. We can also call this side B. The opposite side to C, the right angle, ends up being the hypotenuse. And so we would say AB. It's super important to know that opposite is the one across from those angles. Now, for the next part, we see a different triangle here. This says we want to mark starting from angle A with respect to A. So we're going to put an arc right on A. And then it says we want to identify the opposite side, the adjacent side, and the hypotenuse. From A, the opposite side is going to be BC, and I'm going to write opposite right there. The adjacent side, AB, is the one next to. And we're going to mark that ADJ for adjacent. And finally, the hypotenuse is always across from a 90-degree angle. So we're going to call this hypotenuse. And we just write a little less than the full word to save time, H, O, and A. So notice it all depends on where you're starting from. To see this, you're going to watch a quick video right about now. So notice here, it's marked angle F. This would be the opposite. This would be the hypotenuse. And this would be the adjacent. Right here, it's telling us to start from angle R. This would be our opposite. This would be our hypotenuse. And the other leg would be our adjacent. For this last one, notice that we're now talking about angle K. This would be our opposite. Our hypotenuse is always across the right angle. And this would be our adjacent. Alright, one more part today. We're going to use those markings of opposite, adjacent, hypotenuse and use them to figure out the missing sides of a triangle. For today, we're going to learn about sine, cosine, and tangent. So, theta is used as an angle placement, almost like an X. Sine is actually on your calculator as SIN, is the ratio of opposite over hypotenuse. So, cosine is the adjacent side over the hypotenuse, ka. Tangent is the opposite side over adjacent, toa. Soka toa, soka toa, soka toa, soka toa, soka toa. You should memorize this pattern so you can actually generate these later on. Now, based on that, we're going to do this bottom part and then call it a day. So, we know tangent is toa, so it's opposite over adjacent. Sorry about the little blur there. We know B, or sine, is opposite over hypotenuse, so, and cosine is the adjacent side over hypotenuse, ka, so ka toa. So here below, we see we have a triangle. We're talking about B every single time. So this is my opposite, this is my hypotenuse, and this is my adjacent. So the tangent is opposite AC over adjacent, BA, aka 3 over 4. The sign is opposite, AC, over hypotenuse, BC, aka 3 over 5. Finally, our cosines are adjacent, BA, over our hypotenuse, BC, aka 4 over 5. We're going to be using these ratios to find missing figures throughout the rest of the week. Trigonometry is going to be super useful for us in math. If you need any extra help, these again is called trigonometry. If you look that up on Delta Math, you'll see some awesome example problems. See you tomorrow.